Aquaculture wastewater is a common source of pollution, containing a large amount of suspended solids and other harmful substances, posing serious threats to the environment and water quality. To effectively treat aquaculture wastewater, many treatment methods and techniques are widely applied in practice, including the method of using dissolved air flotation to remove suspended solids. The principle of DAF to remove suspended solids is mainly to use the adsorption effect between microbubbles and suspended solids, making the suspended solids float to the water surface, thereby achieving removal. DAF injects air into the wastewater, producing microbubbles. When the microbubbles combine with the suspended solids, due to the density difference, the suspended solids gradually float to the water surface, forming foam. By collecting and removing the foam, the suspended solids are effectively removed. To verify the effect of DAF on removing suspended solids, we conducted a series of experiments. The experiments selected different types of aquaculture wastewater. And set up different experimental groups according to different treatment conditions and parameters. The DAF model used in the experiment was a dissolved air flotation machine, and the operation process was as follows. The wastewater was introduced into the DAF, and air was dissolved in the wastewater by pressurization, and then released at atmospheric pressure. The microbubbles produced after release combined with the suspended solids and floated to the water surface. During the experiment, parameters such as the removal rate of suspended solids, the number and size of microbubbles, and the water quality of wastewater were recorded. The experimental results showed that DAF had a significant effect on removing suspended solids, and the removal rate could reach 99%. In the experiment process, we found that the number and size of microbubbles had an important influence on the removal effect of suspended solids. When the number of microbubbles was small or the size was large, the removal effect of suspended solids was poor, while when the number of microbubbles was moderate and the size was small, the removal effect of suspended solids was optimal. In addition, the water quality of wastewater also had a certain impact on the removal effect of suspended solids. When there were more impurities in the wastewater, it would affect the adsorption effect between microbubbles and suspended solids, reducing the removal effect. Through experimental verification and analysis, we draw the following conclusions. DAF is an efficient and environmentally friendly method for removing suspended solids from aquaculture wastewater. Under suitable operating conditions, it can achieve a 99% removal rate of suspended solids. However, in practical applications, factors such as water quality and treatment cost also need to be considered. To improve the removal effect of suspended solids, DAF's design and operation parameters can be further optimized, such as improving gas dissolution effect, increasing microbubble number, and improving wastewater pretreatment.